I'm TC from Storage DNA, and I'm here today to talk to you about DNA Evolution. It's a recent product we launched at NAB, and we're really excited about it. And what we're really doing with the product, as you'll see as I talk through it, is enabling data management for media. And it's a very wide topic, and we understand that. And we've done a lot of work to address all the all the issues we see as part of this big wide topic. So going right in, a little bit of background about our company. We're based out of Irvine, California, which is just south of Los Angeles. Really nice weather. Our first product is DNA Sync, which we launched a couple of years back. And really what our background is, we are IT guys coming into the media world and building IT technologies focused on media. And the first product we built a data synchronization engine. So it's really, really good at moving huge amounts of data between SANs, keeping your SANs synchronized. I hope that's not me. Yes, it is. It's my wife. I'll not take it. So it's really good at keeping huge amounts of media synchronized. And, people use us, our customers, existing customers are guys like DreamWorks, and they synchronize, 50 to 100 terabytes between LA and San Francisco. And they do it so that their SANs are protected. There's disaster recovery. And editorial teams make changes on one side and the other guy's side gets to see it. So we became very, very good at moving media really quickly and really effectively. But that's not what I'm here to talk to you about today. I'm here to talk to you about DNA Evolution. Last year at NAB, IBM released a technology called LTFS, or Linear Tape File System. How many of you guys here are aware of what LTFS is? Just a quick show of hands, don't be shy. I'm going to ask you questions. So, what LTFS is basically is, you know about HFS or NTFS for a hard drive. You format a hard drive. IBM now allowed you to format a tape, and it made it look like a hard drive. So what it really excited us about is, hey, we could just take our media movement engine and now point it to tape. And that was great because now we could not only go to disk, but we could also go to tape. But life wasn't that simple. When we started talking to customers, we realized that you need a lot more intelligence to be able to manage data for the media environment. And what I'm here to kind of talk to you about first is, what did we really learn and why did we design DNA Evolution the way we did? And then I'll go into details of what DNA Evolution can provide you. So the best way to describe it is that's your, stereotypical file-based workflow pipeline, all the way from capture, ingest to export, distribution. And what we found was that there is a tremendous amount of data being shoved into this file-based pipeline right from capture. We're talking about all kinds of file-based media that is being kind of shoved down the throat of this pipeline, and this data explosion is traveling through the entire pipeline. So every storage medium that's supporting the pipeline is getting taxed. It's breaking and bursting at its seams. And we realized that it wasn't as simple as giving customers a solution to put your files on tape. We realized that it had to do a lot more than that. So that's what DNA Evolution does, is that it's a data management layer. And a lot of what I'm saying is very abstract, but it'll get more concrete in the next few slides. But it's a data management layer that really plugs in and is designed to plug in alongside your entire file-based pipeline. And it offers you data management services along the entire pipeline. Specifically, what services does it offer? Archive, backup, and media migration. So it helps you archive media at the stage of the pipeline when you need to. It helps you find it, bring it back. It helps you back up media at the most critical points in your pipeline so that if you go down, you can recover right away. It helps you keep your SAN space in check by intelligently moving off inactive media and pulling stuff back when you need it. And we're a bunch of software guys, and we realize that you hear LTO5, LTFS, nearline disk, XDCAM. Well, I think you guys should use all of it. And the reason is because each storage medium offers a different value in terms of cost, performance, and reliability. And you guys should decide, and we as a software vendor should let you use whatever medium you guys see fit. And we obviously build this into a highly clustered and scalable architecture So you could go from, archiving 10 TB to LTO5 to all the way to petabytes. So to make things, as I said, a little more concrete, what I'm going to do over the next few slides is describe to you what services we provide along this pipeline. So I'm going to start up front, which is capture to editorial to online to final export. And I'll kind of highlight what we are doing along the way. So let's take the first one, content capture. Graham spoke a lot about this, but the key challenge we realize with customers is you guys have lost your tape master now, because everything is coming in on a P2 card or a USB drive. That's not your master. You can't keep that for 30 years and expect to go back to it. So the first thing that makes clients really nervous is that, hey, I want my tape-based master back. That little dusty piece of tape, I knew that was my last resort. So what we do here is DNA Evolution can take a lot of that LTO, take a lot of that raw media coming in from the field and start putting it on LTO5 for you. And it's using the LTFS file system to write it on so you can get your data back in an open fashion later on, even without using storage DNA, which is a very critical part about a long-term archiving software. Can you get to your data without the software itself? Well, yes, you can with us. The other thing that's very important is, can you make multiple copies of the tape? And yes, the DNA Evolution lets you make multiple copies very easily. So you can put, one in, you can give one to post, and you can put the other one in a content warehouse. Can you reliably delete content off of your media after guaranteeing that it's on tape? Yes, we do, because we have an advanced checksumming algorithm that actually matches every file that's on source, checks it with what's on tape, and then removes it from the source. Well, can you find petabytes? Can you find the needle in the haystack, right? Can you find your media that you archived a couple of years back? Well, yes, you can with us, because what we do is while we put the high res onto LTO5, we're taking previews or proxies that could be generated by a transcoder. We're taking metadata that we extract from the file and XML metadata that you can add, and we're putting it into a web engine that you can now search and find all your media. So right at the beginning of the pipeline, we're now giving you a way to archive, search, checksum, delete, verify, and retrieve media extremely effectively. So that's what we do at the beginning of the pipeline. But what happens right after media comes in? Well, you ingest it into an editorial SAN. This ingest or transcoding process takes a very long time. In this phase, a lot of customers said, what if my SAN blew up? What if somebody did a consolidate and blew away media? So here you start getting into the insecurities of actually actively backing up, not archiving, but backing up your data while you're working, so that if you do have some kind of a hiccup, you're not going to spend a week trying to recover when your project's going to get delivered in a week. So here we become a backup engine. Think of us very much like Time Machine, but we're able to plug into any SAN that you have and actively synchronize or mirror that SAN to a nearline medium of your choice. You can go to a autoloader with a bunch of LTO5 tapes, or we could go to nearline disk. Once again, that's a choice you guys can make on your recovery requirements, basically. So in this phase, we're becoming an active backup engine. Now, if you move further down the pipeline, one of the things that you keep hearing about is, how full is your SAN? It's 99% full. What do you do? But one of the things that I've found has been unfair to end users is that, yes, your SANs are 99% full, but it's not out of choice. Now, you guys have lacked a tool that lets you move media out effectively, guarantee that media is on a medium you guys trust, guarantee you that you can actually delete it from your SAN, because these are all gut-wrenching exercises. I'm going to move my media and I'm going to delete it from my SAN. I mean, come on, give me a break. It sounds... And that's why, most end users go and just buy more SANs, right? But when we looked at it, we said, okay, how about if we give you a really easy way, and give you the warm and fuzzies that you can actually move the media out and actually delete it. But most importantly, what a lot of people don't touch upon, that we really touched upon, is how easily can we let you get media back, right? I want a sequence back. I want to edit this sequence because the customer's back and they have money now. So, maybe I'll edit their sequence now, right? So what we did here is we came up with really intelligent workflows for both Avid and Final Cut. What you can tell us is in an Avid environment, you can go say, hey, go scan all my Avid Unity workspaces and go look for media that's belonging to a certain project. So we open up the MXF file, look at the project name that's stamped on it, and only if the media is greater than 100 megs and older than 60 days do I want you to archive it off. And then I want you to checksum that against the tape, against the source media, and only then remove it from my Unity. So we'll go intelligently and do that harvesting of data for you. And we do the same thing no matter what SAN it is. We can do the same thing for QuickTimes or MOVs or pretty much any kind of SAN you have. Is we can go there and pick up all this old data and reliably move it out for you. But more importantly, we have a really cool way to help you bring data back. So in an Avid or a Final Cut environment, an editor comes back, they see a sequence that's offline because all the media is gone. Well, they can now just give us an export, an AF or an XML export of the sequence. We take that export, go find the media from the nearline, and only populate that back for you. So now you have a very reliable and an easy way to push off inactive media, but only retrieve back what you need. Once again, in a very deterministic fashion. What storage medium can you go to? Well, you can go to LTO5 tape, or you can go to disk. Now, moving on beyond editorial, we are also integrating with online environments. And the biggest challenge with online environments is that the size of the media assets you're dealing with now is the raw file. So you're having to keep maybe 10x, 15x the storage capacity online. What we're doing here is we're working with apps like Assimilate, Scratch, and DaVinci Resolve so that based on the XML or the AAF that they receive or the EDL that they receive from editorial, they tell us what DPX frames or red files they need to work on for a certain sequence. And we only bring that back in. So now you're always just keeping a subset of the entire raw media that you need online. Which means your SAN can become, 50 TB from a 300 or 400 terabyte SAN. Once again, these are huge infrastructure costs we're talking about. We're talking about saving millions of dollars. And again, what we really designed this tool was to help you constantly, more effectively keep data on the right storage medium when you don't need it, but quickly bring it back when you do. That's the whole philosophy behind what we've built. That's really the philosophy behind data management. And finally, the easy part, the final export archiving, which is what people mostly do when it comes to archive. Well, we can archive that data as well. That's the easy part. I wasn't given a lot of time, 20 minutes, so I'm going to just throw some concluding thoughts at you guys. We've really worked hard in building a complete data management solution that's going to help you manage your data throughout your pipeline. We've integrated with applications, Avid and Final Cut. We'll very soon have Assimilate, Scratch, DaVinci, CatDV, and Avid Interplay. And one of the points to make again is DNA Evolution is designed to go to disk or to LTO5 tape. And I can talk, if you guys go to our website, and I can talk to you guys more offline on, when is LTO5 the medium to go to, when is nearline disk the medium to go to, and at what stage of the pipeline. A lot of you guys might be thinking, how much does all this cost? Well, we've created some really neat packaged solutions. So our entry point solution comes with a server, a tape drive, and all the software, and it's at $7,995 USD. And we scale from this really tiny package all the way up to petabyte-sized libraries, which is fully clustered and managed to help you manage a whole bunch of data. You can find out more at storagedna.com. So that's pretty much all I had. If you guys have any questions, I can take it now. Don't be shy. You guys are all shy.